In this video, we discuss learning outcome number 1 from lesson 5.1, which is all about random variables and determining whether a random variable or whether a quantity is a discrete random variable, a continuous random variable, or neither. So here's the definition. A random variable is a variable that is typically represented by x and has the following qualities. It has a single numerical value. So it has to be numerical and it's just one value. And it's determined by chance for each outcome of the procedure. For example, when you're rolling a die, the sample space is 1, 2, 3, 4, 5, or 6. Those are all the possible outcomes. That outcome can vary every roll. So it's determined by chance for each procedure, and each of these, 1, 2, 3, 4, 5, and 6, is a single numerical value. So the value that we get when we roll a die, x, is a random variable. Now, random variables represent quantitative data. They are a type of quantitative data, and they can be split into two groups. You have discrete random variables and continuous random variables. So discrete random variables are random variables that have a collection of values that is either finite or infinite but countable. So for example, the number of coin tosses that you would have to do before getting heads, that might be finite. You might do it a few times and then eventually you get, after 2 or 3 times you get heads, or 5 times you get heads. Or it might even be infinite but countable. So maybe you've got a weighted coin that will never land on heads, it always lands on tails. You would just keep counting 1, 2, 3, 4, but you count all the way to infinity. That is like a countable infinity, and a variable that could take on values like that is called a discrete random variable. Now, if I wanted to visualize a discrete random variable, what I would see is a number line that maybe looks like this number line here. You would have distinct points graphed on that number line. Or here's another example of a discrete random variable. The count of movie patrons at a movie theater. If every time somebody walks through the door, we press the counter, and somebody walks through the door again and we press the counter, and somebody walks through the door again and we press the counter. And maybe you've done that 278 times. Well, that is a discrete random variable. Theoretically, you could go on forever. You could keep counting indefinitely. So it might that value might be infinite but countable. And it would still be discrete because we can count it. Now, continuous random variables can never be counted. A continuous random variable has infinitely many values. For example, body temperatures. Body temperatures exist over a range of values, and you've got an infinite number of values from the lowest all the way to the highest. It's impossible to count these items. Because at least some of them are on some kind of continuous scale. That's why we call it a continuous random variable. So we've got this number line here illustrating this idea, and we've graphed the interval from negative infinity to infinity. But it really doesn't have to be negative infinity to infinity. Any interval of values on the real line would work, because there are infinitely many values between 4 and 6, even if we're just talking about the values between 4 and 6. If we tried to count them, we would always miss some. And if we had 2 values and we tried to put them very close together, there would always be another value in between. And then between 2 of those values, there would always be another value in between. We could never count them, even if we tried. So that's what we're talking about when we're talking about a continuous random variable. It can be graphed on a number line in an interval like this, rather than that list of discrete points, or that picture of discrete points like we have with a discrete random variable. An example of a continuous random variable is measured voltage. Voltage exists over a range of values. So if we measure the voltage on a battery, that's a continuous random variable. Now here's an example. We're asked to determine whether a quantity is a discrete random variable, a continuous random variable, or neither. And here's the quantity. First, we've got exact weights of the next 100 babies born in the United States. Well, we're talking about weights. Weights can be found over a range of values. So that's a continuous random variable. Now we've got responses to a survey question. Which political party do you prefer? Well, the answers would be political parties. They wouldn't be numbers. Since it's not numerical data, it is neither a discrete random variable nor a continuous random variable. If we talk about the number of spins on a roulette wheel to get a certain number, well, every time you are counting, every time you spin that roulette wheel and then you count that, it's a count. So anytime you're counting something that is a discrete random variable, it's countable. Exact foot lengths of humans, lengths of feet vary over a range. So those are continuous. That is a continuous random variable. And shoe sizes. You could have a shoe size of 8 or 8.5 or 9, but you never have 8 3/4. They haven't come out with that shoe size yet. And even if they did, they probably wouldn't come up with infinitely many shoe sizes between shoe size of 8 and shoe size of 9. So this is a discrete random variable. So that's it for our discussion of random variables, discrete random variables, and continuous random variables. I'll see you in the next video.